So you've got this perfect blueprint for a new software system. The designs are all approved, the plans are totally set. But what happens next? I mean, how does a brilliant idea on paper actually become a living, breathing tool that people are going to use every single day? Let's break down that exact journey from blueprint to reality. Right. The design phase gets all the glory, doesn't it? It's often seen as the most creative part. But turning that design into a functional, stable system, that's where the real heavy lifting begins. It's a journey with some really distinct phases, critical tests, and a high-stakes launch that pretty much determines whether it's a success or a failure.
First things first, we need to get two key terms straight: construction and implementation. The easiest way to think about it is like building a house. Systems construction is the actual process of building the house. Developing, installing, and testing every single piece, from the plumbing to the wiring. Systems implementation, on the other hand, well, that's moving day. It's the final delivery of the entire system, ready for you to live in and use day to day.
Okay, so let's start with phase one, assembling the system. This is the construction phase we just talked about. This is where all those individual technical pieces get put together. It's the crucial behind-the-scenes work that makes everything else even possible.
During construction, the team is laser-focused on four core tasks: building and testing the networks, building and testing the databases, installing and testing any new software, and finally, writing and testing all the new programs. You're probably noticing a theme here, right? Build, test, repeat. It's a cycle, and it's designed to catch issues early, way before they can become massive headaches later on. Now, testing isn't just a single event. It actually happens at multiple levels. A stub test might check just one tiny piece of code, like making sure a save button actually saves. A unit test then checks the entire program that button is a part of. And finally, a systems test makes sure all those different programs and components work together without crashing. It's like testing one brick, then a whole wall, and then the entire house to make sure it's going to stand strong. All right, so once all the pieces are built and tested, we move to phase two, the big launch. This is the implementation phase, that high-stakes, moving day, where the system finally gets delivered to its users and actually goes live. But wait, before we hand over the keys, there's one final round of testing, called system acceptance testing. This happens in two stages. First is verification, or alpha testing. That happens in a simulated lab environment, using fake data to make sure we built the system correctly, that it matches the blueprint. Then comes validation, or beta testing. This happens in a live environment with real data. This is where we test performance and usability to confirm we built the correct system for the people who will actually use it. So how do you actually switch the thing on? Well, the team has to pick from four main strategies. An abrupt cutover is exactly what it sounds like. It's the high-risk, rip-the-band-aid-off approach. Parallel conversion is much safer. You run both the old and new systems at the same time, but boy, is it expensive. You could also do a location conversion, rolling it out one office at a time, or install it in manageable chunks with a staged conversion. Each choice is a trade-off between risk, cost, and control, and the right answer really depends on the business's needs. Look, you can have the most brilliantly engineered system in the entire world, but if people don't know how to use it, it's a failure. It's that simple. This makes user training absolutely essential. The systems analyst is key here, responsible for planning the training, writing the manuals, and just guiding users through that initial, and let's be honest, often tricky learning curve. And all of this leads to the most critical moment in the whole process, the handover. The project team has done its job. The system now belongs to the business and the people who will use it every single day. The keys have officially been transferred. But the journey doesn't just stop at launch, not even close. Now we enter the longest phase in any system's life: operation and support. This is all about keeping the system healthy, helpful, and running smoothly for years to come. System support really rests on four key pillars. You've got system maintenance for fixing bugs, system recovery for when things inevitably go wrong, technical support to help users with their day-to-day questions, and finally, system enhancement, which is all about improving the system over time. First up is maintenance. This is basically the process of correcting bugs. Those annoying little errors that somehow slipped through all that testing. Bugs can happen for all sorts of reasons, from a simple coding mistake to a requirement that was misunderstood way back in the design phase. Maintenance is the essential work of squashing them. But support isn't just about fixing what's broken. It's also about making things better. That's system enhancement. It's the process of improving the system to handle new business problems, new technical challenges, or new technology. A business never stands still, right? Well, neither can its software.
And this leads us to the system's final chapter. Because, like everything else, software has a natural life cycle. It's born, it lives a productive life, and eventually it reaches an end.
It's a simple but really powerful truth. Over years of maintenance and enhancements, systems just get more complex and more brittle. Eventually, it becomes too difficult and way too expensive to keep supporting an old system. Its time is up. But the end of one system's life isn't a failure, not at all. It's actually what triggers a brand new systems development project. Obsolescence is the engine of innovation. It brings the entire process full circle, creating the need for a new design, a new construction, and a whole new implementation. And this leaves us with a final, pretty thought-provoking question. Throughout a system's life, there's this constant tension, right? A tug of war between maintaining what you have and just starting over. So, when is it better to apply one more patch versus admitting the old house is no longer sound and it's finally time to build a new one? Something to think about. Thanks for tuning in.